All right, so I'm going to be talking about decorators. And it's OK if you don't even really know what they are. If you're using Angular, though, you're probably using them. But first off, it turns out that this is a really bad title. A lot of other people have used the whole diving into decorators thing. And I had already made the slides, so I didn't really feel like changing it. Oh, yeah, for sure. Let me make it full screen. Oh, that didn't do. What was that? I just hit F.
Did you hit?
I have no idea what just happened.
Hit back?
Yeah, back. Why did, OK. F. There we go. All right, now we're full screen. Yes, so there's already some JavaScript talks. There's Python blog posts, all that stuff. But none of them actually used diving GIFs or any references to diving. So I'm going straight into it and buying into the diving completely. I hope it's not too painful. So starting off, what is a decorator? This is the official description that's on the spec. It's a lot of words. But basically, it's a function that transforms either a function or a constructor or something like that. So if we look a little further, there's other languages that have decorators. So Python has decorators. Java has annotations, which are very similar. C# has attributes. And they all really do kind of the same thing. They cut down on boilerplate and let you like declaratively decide what's going to happen in your code. And really, the JavaScript decorators look a lot like Python's decorators. So that's kind of why they took the name. So the spec proposal is at stage 2 right now. And if you're not familiar with the stages, there's basically 4 stages of the proposal process. There's stage 0, where they've created it, and they're like, hey, we want to make this thing, but there's no code for it yet. There's stage 1, which I think requires at least 1 implementation. Stage 2 requires 2 implementations. So basically, this has advanced to stage 2 because there's a Babel transform, and TypeScript also has decorators. So that is 2 implementations that they can then advance the process with. The only issue is TypeScript and Babel don't actually use the stage 2 syntax. They're still using the stage 0 legacy transform. So one of the interesting things is in Babel 7, the default is going to use the Babel 5 decorator behavior, which is really stage 0. And the issue is just none of the compilers are supporting the stage 2 spec yet. And that will happen eventually. But right now, if you go and look at the spec, some of it might not make sense to what actually happens in your browser when you're testing with it. So now if we look at some examples, this might be hard to read, so I'll read them out for you. But we have the @component decorator. We have the viewChild decorator if you want to reference something from your template. We have inject for injecting services. And we have a lot of cool things like even a host binding, which allows you to like listen to your scroll events and things like that. There's a lot of really cool stuff. And if you're going to write this yourself, that's a lot of boilerplate that you'd have to repeat. We're really like, you know, host binding right there, and then the thing you're listening to, and then you just react on it. It's really cool. So there are multiple types of decorators. So we saw the component decorator. That's a class declaration. But if we look at maybe a method decorator, which was like the event listener we had, they have slightly different syntax on the parameters that they take in to do stuff to whatever you're trying to decorate. So now if we actually look at a really basic example, let's check out a class method decorator. And we're going to say, here's a method that's deprecated. So we have a library that people are consuming. And let's say we have this make widget function. Eventually, we don't want someone to use this, but we don't want to just break a bunch of people's code. So we can have warnings put out to their console while they're developing, which is kind of useful. So the idea is we're going to create this deprecated decorator. We're just seeing how it kind of works here. And the idea is we would have deprecated here, and then when we call the method, we would get this logged to our console. So if we were going to make that decorator, here's what it might look like. We're going to have a function called deprecated, because a decorator is just a function. It's going to take in a target, a name, and a descriptor. So the target is going to be basically the object we're operating on, usually the constructor or things like that, maybe the prototype. The name is actually just the string name of the thing so that we can actually log the widget utilities, make widget stuff. And then descriptor is this kind of metadata that tells you what you can do to this method. So if I wanted to edit the descriptor, I could make something read-only. or write once. And there's a lot of really cool stuff you can do with metadata, which I'll get to a little bit later. But what if we wanted to actually pass arguments to that decorator? You know, say we want to actually change what the message might be when we're outputting that deprecated message. So here we have deprecated as a function. This is how we would use it, and then we're going to write the code to actually make it. So we have deprecated as a function. We actually call it like a function using an argument and parentheses. And then it just simply does some magic to this makeWidget method and gives us that whole message right here added to it at the end. So now if we want to see that, it becomes a higher order function, which is really just a function that returns another function. So here we have our message that we're passing in at that top level, and then we still have the function with the target name and the descriptor that are returned and then used by the compiler. So now we're basically just doing the same thing of replacing that method, calling it again, and warning before it. But now we can use the value that was passed in message. It's pretty cool. The other cool thing about decorators is they're stacking. So depending on what order you put these decorators in, let's say time tells us how long it took to run that method. Deprecated is going to do our basic deprecated method. The issue here is if you put time before deprecated, you would be measuring the time it takes to output to your console the deprecated message. And that doesn't matter as much when you're doing just time tracking. So one thing to be careful of is how you handle your stacking of your decorators. And really, it's just if you're calling a method or a function onto a function onto a function, it's how you would nest them. The top one is the outermost thing. So now you're thinking, OK, cool. We just made that deprecated method decorator. But what if we don't want to create all of our own decorator methods? There's actually some really good core decorator methods and Lodash decorators as well. Core decorators is going to give you things like read-only, and a whole bunch of other basically like core things that the compiler can use, and like real like awesome stuff that even other languages kind of have, and we have to like hack into place. And then Lodash decorators is great. So that'll give you things like memoize. You can cache results from a method using just a simple memoize decorator. Really, it's an awesome library. The thing to remember, though, is they're still using the stage 0 version of decorators. They both have issues created in their repo that once the stage 2 version has a compiler, they'll both start supporting it. But they can't really write code for something they can't compile. So that's the main issue there. But yes, Lodash decorators is going to save you a lot of time if you want to, say, debounce a class method or something like that. Is there anyone not familiar with what memoize and debounce actually do? I can go into that a little bit if you need. OK, so memoize is going to take your method, and based on whatever arguments you're passing in, it's going to cache the result of that function. So you don't have to run the function anymore. You can just look at your cache for the parameters. And because it's a pure function, you're always going to get the same result back. And then debounce is, let's say you have a window listener that you only want to like really listen to, or let me have a better description, I guess. So debounce, let's say a user is clicking a button a bunch, and you only want to get one button click from them. You can debounce that to get 500 milliseconds from the last click. So theoretically, they could click, 500 milliseconds pass, and the method fires. They could click twice, and then 500 milliseconds from the last click is when your method fires. It's a really nice way of just making sure you're not like letting the user destroy your app by just doing something too many times. So now we've kind of dove into decorators a bit. That was a little smoother, I hope. We're going to go into like a real example of Angular's component decorator. So here's the usage of it. If you're doing Angular, you're kind of familiar with this. But basically, we have @component, and we're going to tell it the selector. That's going to be the what we use in our template to find that component, right? We're going to have the template URL that we're going to use to create this component and render it to the page. And we have the style URLs that we're going to use to make it pretty. The cool thing is, using that after compiling, we get this stuff on our metadata. Instead of being as part of our component, like when you do a console log of your component, you're not going to see any of the template or the styles, but the compiler has already put those into the metadata. Whoop. Sorry about that. I do not use those hotkeys for navigation. But yes, basically, here we have the template already compiled, already has values injected into it. Here we have our styles array, which is already compiled SCSS. So we no longer have variables right here for color. We have the actual color. So it's kind of cool how Angular compiles all this down and makes it its own self-contained unit. Like, this is just metadata attached to our actual component, instead of like AngularJS, where you would have a separate JS file of your compiled templates. So now if we log the component itself, as you can see, we don't see any of that style URL stuff. All we see is from the tour of heroes, we have our hero service, our hero, and our route params, all the things that are actually passed into and matter to our business logic of the decorator, of the component. So now that kind of brings us to metadata. And metadata is basically, it's data that pertains to the code itself, not really to like the logic of the code. So once again, it's like the name of the component. It's the styles attached to it, things like that. Those don't matter when we're trying to implement a click handler, really. The thing is, it's not actually part of JavaScript yet, so there's a shim for it. And what it's doing under the hood doesn't matter as much. My guess is they're keeping some type of global singleton that kind of stores stuff based on hashes and things like that. But really, you just have this shim that you can use that Angular already has bundled that you can then start reflecting on the metadata to inspect stuff. So then that would look like, hey, I'm going to define metadata on this thing. So if we look reflect.define metadata, we would pass in the key, the value, and the object that we want to add metadata to. And then we would maybe look at if it has our metadata. So it really has a whole bunch of methods that we can use. Oh, where's my mouse? To go through and like look at the metadata that maybe Angular attached for us, and we want to debug something that we just don't understand how it's going. So it's kind of cool. You can look at metadata for properties, for methods, for classes, all sorts of stuff. It's really, really useful. And Angular is already using it under the hood for almost everything. Inputs, outputs, a whole bunch of stuff. So that does wrap it up. I probably talked way too fast. If you have some questions, feel free to ask. But there's also some citations and further reading that you may want to look at. So there's the specification itself. There's a 4-part blog series that I really recommend. It really helped me understand them a bit better. And then there's the TypeScript Playground, which is basically a place where you can just code away. And it's like JS Fiddle or something, where it'll compile your TypeScript for you, and you can see the output to regular JS, which is really cool. So now that we've kind of dove in together, you can start diving in your very own way. Maybe like Rodney Dangerfield and the Triple Lindy here. I don't know if anyone's seen the film, but it's a classic. I really recommend it.
You can tell it's a stunt double.
I'm sorry, say that one more time?
You can tell it's a stunt double.
Oh, of course, yeah. I don't think Rodney Dangerfield would do this himself. Are there any questions, though? Because I did go a little fast through that. I can navigate back through slides if you guys like. That's fine. Yes?
Do you know what version of the spec Angular is using?
TypeScript uses stage 0 still. So Angular is using TypeScript. Yep.
Where in your code base would you define decorators?
Really, it's just a separate file that you would put in maybe like a utilities folder or something. Just yeah, and then you would import it just using standard import syntax, because really it's just JavaScript at that point.
On the core decorators, is there documentation that says what they have already?
Oh, yeah. I think that's a good call. I can navigate to that page for you. Let me see. Yes. And yeah, I can show you guys the Lodash one as well. But basically, yeah, here's the whole list of what it has. And some of these ones that are deprecated because Lodash Decorators is already doing it, so they don't really need it in this repo anymore.
Cool.
Yep. And yeah, I'll go navigate back to the Lodash one for you as well, because that's pretty cool. Yes. Yeah, so here's a good list of them. Okay. Yeah, it's basically almost every Lodash method could be implemented as a decorator, because they're just pure functions usually, so you could just really wrap them and do whatever you like. So there's a whole bunch of stuff you could use. If you're using Lodash in your projects, you could probably use Lodash decorators and save yourself time. Anything else? Awesome. Thank you, guys. I really appreciate the chance to talk.